Wake Workplace, it's a collaboration platform ecosystem that consists of the several tools that will help you to work with other people towards your goal and purpose. So we have mail application. I won't describe what is mail and go further. We have chat application. We have video conference application, calendar, and of course T-Drive, about what I will talk today. And all the products are integrated and communicates with each other. So to begin with, I want to tell you about our starting point. It's important for this speech. It's a previous version of the Wake, old Wake. So it was more or less a product about the same goals, to help people to collaborate, but it was more like open source Microsoft Teams. If you will look at the screenshot, you will need to spend time to find 10 differences. It has messaging documents, the same calendar and tasks that will help you to communicate. But we've decided to rewrite it. We've decided to rewrite it almost from scratch, and we've decided to rewrite it because we want to be open. Open not only in terms of the open source, but also open in terms of the architecture, to use open standards, and that will allow us for this almost 5 reasons. It will allow us to be more secure because it's open standards. Everyone can see your code, what you're developing, what about your protocols, and it will be easy to support. Also, you have more credibility. If everybody will see your code, what you are running, you have more trust from the people that are using your product, also in terms of the security. And also it will allow us to collaborate and to work together on the protocols, to work together on the applications. So we've decided to rewrite on from scratch, but for Wake Drive, we forked the old Wake application, and we've developed it further, we've modified it. So we forked it and we had MVP in 3 months. It was a working MVP with these functions. You can store files, upload it in multiple different ways. You can create documents through the OnlyOffice integration. You can search the documents, search just regular search by content inside the document. You can share documents by the link, or share documents inside your team, and also you can collaborate and work together on the documents also through the OnlyOffice integration. About the architecture of the application. So it was Node.js and React.js application for the front end. For the metadata database, we made application distributed to make it able to scale. So for the database, it's a Cassandra or MongoDB. For the distributed search, it's Elasticsearch or MongoDB. And to storing object, it's like a 3 compatible object storage. Of course, everything could be run in Kubernetes and orchestrated and monitored with Grafana and Prometheus. So, and we've modified our architecture. We modified it. We've added support of the more databases. I will speak about it a little bit more later. We've added support of the PostgreSQL. We've added support of the OpenSearch, mostly because Elasticsearch doesn't have the license of the OpenSearch is not totally open. And also we make the middle layer of the application more modular and more scalable, because also I will speak about it later. And we added integrations with OnlyOffice, with OIDC, stuff with the OpenOffice server, and we made the application more secure. About the architecture of the application. Is it microservices? No, it's not microservices. It's a little bit holy war topic, and before, I think several years ago, in every software conference, you will see multiple speeches about the microservices and microservices architecture. You can consider our architecture is monolith, but modular. Why we didn't go to microservices? It's because of mainly this reason. It's time consuming to support the same tooling and the same code standards for every microservice. It's more expensive to integrate each microservices in your build CI lifecycle and release lifecycle also of your application. And it's more easy to support and profile, especially for a small team. If you have monolith application, just check out application, put a breakpoint, and you know where is your bug. But with microservices, you are not able to do this. But we've moved some very resource-consuming operation to the separate services to make it more easy to scale. The most time-consuming operations for the Twig Drive application, it's generation of the preview files and parsing the file content to make it searchable. And we moved everything to this server layer. So we've split our application into services. Each service you can consider as a separate application that has its own connection to the database, its own HTTP layer, and all of the applications are independent. They have started in the platform through the dependency injection and communicate with each other with the message bus and for packets that we can maybe later transform into something more near to microservices. So this is a piece of code that looks how the platform is started. You just list services that you want to be started inside the application, and you can have it like this. You can have it list in the configuration. You can put a path where these services are located. And also you can switch modules regarding your security policies, because we want to make our application more secure. I see spammers, and that's a joke, and that's true, because if you are releasing your service in SaaS, it's almost 100% that your first users will be spammers, and any other guys who will try to use your service not in a good way. When we were releasing the previous version of Twig, as I've said, it was open source Microsoft team, and it was rather closed applications without any external communication. But even there, we have spammers who will try to spam through our platform with the invitation process, and you will need very strict rate limits, very strict security policies, and even with these strict security policies and rate limits, you will find people who will try to find a way how to spam through your product. So we will try about the security. 3 states of the data that we have right now: at rest, in transit, and in use. When we store data at rest, so everything encrypted in the metadata database, everything encrypted with the company key. Every file that we store in the storage encrypted with its own key, and every key also encrypted. When the data is transit, it's encrypted by SSL, and when data is used, it's not encrypted because you are using it in the browser. The main reason we do not support right now P2P encryption, because we have only web browser application, and it's very complicated to implement P2P encryption in the browser. It's easy to implement, but it will be not easy to use for the end user. So we will come back to P2P encryption when we will have mobile application. When Twig Drive will have mobile application, we will add the P2P encryption for the mobile application. So, also about security, nothing is cached, nothing is logged. When you upload your file in the browser, it's directly through the streams go to the object storage. So we split file into chunks. Each chunk is encrypted separately, and for each chunk, there is a direct stream from your browser, from your hard drive to the object storage. Just with security, and we split in the chunks, and there is just several pipes in the several services that will allow to transfer data in small pieces and do not have the whole file anywhere. Metadata encryption and how we implement it. We implement it with symmetrical encryption with AES 256 algorithm, and we made it with custom ORM because it was very easy to implement. You have custom decorators where you should put just OK, encode this file into the JSON, encrypted JSON, and you have these 3 lines of code that will just encrypt and decrypt everything. It was very easy to implement and to do it with this custom ORM, but it has several drawbacks. I will speak about it later. Because also, okay, we have custom ORM. Then we will generate all the database query with this ORM. Why not? So also we made the application more extensible and to be able to communicate with the other application. Right now, we do not implement any open standard in the Twig drive. We will implement WebDAV. It's planned by the end of this summer, but now, no. What we have HTTP API, we have integration with the ODC providers. You can integrate your application through the event message bus and consume events from the T drive. And we have also applications, abstractions inside the application. It's kind of plugin. You describe your plugin, you describe how it should behave, what API it should call, how it should look like inside the application. In this example, you see just only Office integration, like it integrates in the context menu. And when you click on this button, for example, create Word document, it will appear a window when you can create document. So next point, we forked the old Twig drive application. It means that we need to deal with legacy. One is this ORM. At first, we supported MongoDB and Cassandra. And it's absolutely 2 different databases with different model structure, with different schema, with different query capabilities, with different way how you write the queries. Why we supported multiple databases? It's because we want our drive application run on several environments, different environments. You can use Cassandra for very big installation of the Twig drive, geo-distributed with multiple servers. But if you run it, I don't know, on your local NAS or for the small company for 10 people, there is no need. It will be very costly for you to support the Cassandra cluster. And this is the example. We have in Twig drive, we have versions for every file when you can upload or download exact version of the file. And for every file, you need to have a list of version. And for every user, you want to have a list of versions that was created by these users. And in the very first example, in Cassandra, we need 2 databases, 2 tables to make it work. You have file version with the partition key file ID and version ID and created that as a clustering key. Or you can convert it in time UID, no matter. And you have user version with the partition key user ID and the cluster key version ID and created that. So this is 2 tables. I don't know how deep I should go into the Cassandra query model and the modeling data for the Cassandra. But to avoid cluster scan, full cluster scan, you have to have this partitioning key. There is no way until you will have, I don't know, dozen millions of records, everything works fine in every database, no matter data model you have. But after, you will need to do these optimizations 100%. And in MongoDB, it's just one collection with file ID, create a tag, fields. You can add indexes on these fields, and everything will work. More or less good. So how we solve this problem? We've added support of the third database. We've added support of the PostgreSQL. It's like something in the middle. It will allow us to have medium installation because one single instance of the PostgreSQL supports from 10,000 to 70,000 random read and writes per second. It will support 1 terabyte table without any very complicated partitioning, and it's SQL. It's very easy to develop and very easy to optimize. So we've added the support of PostgreSQL, and also we moved the support of multiple databases to the service layer that I've described previously. From ORM to the service level. So you can have, for example, in the same Twake drive running instance, one service that is working with Cassandra and another one that is working with PostgreSQL and Mongo. Other fun that we dealt when we were developing the Twake drive application. Dealing with legacy, lack of documentation. So these to-do files, when this documentation is not to date, it's 100%. If you are forking some legacy product, you will find these to-dos. Outdated dependencies. It's very, very important for the security reasons to fix such kind of warnings. And if it's legacy product, it won't be easy to fix because some products, especially in the Node.js and especially in the JavaScript ecosystem, they don't have backward compatibility. You will need to rewrite from scratch. And the technical debt, this to do on the top, that is temporary and should be deleted. This to do was 5 years old. So, and you will find a lot of such kind of to-dos. It's also another topic, how to deal with the technical debt in the product, but it's also for another speech. What's next? This is our roadmap. Right now we have only on-premise installations of the Twake drive with some of the client. I think the biggest installation is 10,000 or 15,000 users and 50 terabytes of data. We are planning to release our public SaaS service this June. Also, this year we are going to develop desktop application and mobile application, and to add more plugin application management to make it more easy to integrate another application inside the Twake drive. Also, we want to increase our integration between our product with the Twake chat application, with the Twake mail application, because I don't know, it's very not convenient to send big files through the email. It's very time-consuming and resource-consuming operation. And in most of the services, you can't send big files through the email. But you can send the file transparently, for example, if you are sending file like a link to Twake drive. For user, it will be transparent. He's just uploading file to his mail, but it will be not file, it will be linked to Twake drive. Also integrating with the distributed file system Web 3.0 based on blockchain or not. You also can integrate Twake drive with some of such kind of system right now, because if they support S3 compatible protocol, it's fine. You can use it. But some of them not, and with some of them we want to be integrated. And also integrated with the AI services. These two, OpenLLM and Lin2, we are developing in Agora. OpenLLM is just a large language model. And Lin2, it's a tool for transcription. So it's a tool for transcribed speech into the text. That's what we are doing. And the last about advertisement, a little advertisement. We want you guys, we need you. We also need you in different terms. At first we are hired. We are hired here in Hanoi. We have office in Hanoi. We have offices in Tunisia. We have office in France. We have internship program. So if you are students or you are already developers, you can join us. You can write to me direct message. You can write to me in Telegram and by email. And you're welcome. And also you can join us on GitHub. You can look at the products of what we are doing. Of course, we are looking for the contribution, and also we are looking for some integration. If you're already developing your own product and you think that it can be a part of that Wake workplace, or we can have some interactions between our product, also feel free to write me personally to write on that Wake Drive channel in the Telegram. Also, you can write me on GitHub. Anyway, you're welcome. Thank you, guys. That's all for me.